Hi, everyone. In this video, we're going to talk about the third week AMC8 practice questions. And the questions are mainly about solid geometry and coordinate geometry. First one, in a rainy day, 2 empty containers are put outside. If it takes 1 hour to fill the left rectangular container, how many minutes does it take to fill the T-shaped container? Cool. And we have the front and side views of the T-shaped container. All right, so for the rectangular container, we have 1 hour. So because we want to know the volume of that container, because that tells us the amount of rain that the container collects. So to compute the volume, we do the product of those three numbers, right? So the volume here, that's 10 times 10 times 30. And that's 3,000. And that's 1 hour. 1 hour. Okay, now we can look at the T-shaped container. So I guess we can cut it into 2 pieces, one rectangular box on top and another rectangular box on the bottom. So it's like right here. Okay, something like that. Cool. So for the part on top, the volume, again, we do the product of 5 times 10 times 30. And that's 1,500. So this is top. And then for the bottom, looks like it's a 10 by 10 by 5 rectangular box, because from the side view, we have 10 here and 5 here. And then I guess we're missing that part, but that part is given to us by the front view. So you see the 10 here, that's exactly the part that we're missing. Cool, so for the bottom, the volume is 5 times 10 times 10. And that's 500. Cool, so now we take the sum, and that's the volume of the T-shaped container. 1,500 plus 500, so that's 2,000. Okay, so we see 1 hour is like 3,000. And then if we want to fill up the container whose volume is 2,000, then we can just do the ratio. I guess the hour, the answer should be 2/3 times 1 hour. So 2/3 times 1 hour, and that's 40 minutes. Okay, that's it. Answer is 40. So actually, this question is more interesting than it seems. So I'd like ask you guys the following question. Let me add a page. So what if we have a container whose dimensions like 10 by 10 by 10? 10, 10, 10, instead of the T-shaped container. So now this is our container, 10 by 10 by 10. Then how many minutes does it take to fill it up? Feel free to pause the video, and then maybe you can work on it for a while. All right, so if you get the answer 20, then congratulations, you got the wrong answer there, because actually the answer here is 1 hour, 60 minutes. So why is that? Well, one way to think about it is, if you look at our original container there, the 10 by 10 by 30, we can actually cut it into 3 containers that are exactly the same. So yeah, let me draw a 30 by 10 by 10 container. Okay, and then I can cut it. Now we have 3 containers here. And each of them is like the 10 by 10 by 10 container. So if you just put that container outside, and it will take 60 minutes to fill it up. So if you if you remove the 2 here, then you just put that part outside, then it will also take 60 minutes. And the reason is, well, the rate at which we fill up the container depends on the area of the top, right? If you look at the original question, the area of the top is like 10 by 10 times 30. That's 300. So here, for a 10 by 10 by 10 container, the area of the top is 10 times 10. That's only 100. So so here the volume is smaller, but also you see the area of the top is also smaller. So that's why it will also take 60 minutes to fill up this container. So that it turns out that that's not the issue in the original question. If you look at the question, our T-shaped container is designed so that it has exactly the same top as the rectangular container. So both of them have the 10 by 30 top. Okay, so we don't have any issue there, and our answer 40 minutes still correct. All right, let's move on. Let's see our second question. Use 12 cubes of side length 1 to form a rectangular box. What's the least possible value of the rectangular box's surface area? So first of all, if we have a rectangular box, and we can compute its surface area using the dimension of this rectangular box. So let's say we have A, B, and C, the length, width, and height. Then it has 6 faces, and 2 of them have area A times B. So surface area. 2 of them have area B times C, and 2 of them have area C times A. Right, so now at least we know how to compute the surface area of a rectangular box. Okay, so the box consists of 12 cubes of side length 1. All right, so actually we know the volume of our rectangular box. The volume is 12. And I guess we can, one thing we can do is to look at different cases. So for example, the rectangular box can be a 1 by 1 by 12 rectangular box. Or it can be 1 by 2 by 6, or 1 by 3 by 4, or 2 by 2 by 3. I guess those are the 4 different rectangular boxes we can make using 12 cubes. Cool. Then we can just compute their surface area. So for the first one, we have 2 times 1 times 1, 2 times 1 times 12, and 2 times 1 times 12. Okay, so that's 2 plus 24 plus 24, and that's 50. And for our second rectangular box, we have 2 times 1 times 2, 2 times 2 times 6, 2 times 6 times 1, and that's 4 plus 24 plus 12, and that's 40. Okay, for the 1 by 3 by 4, we have 2 times 1 times 3, 2 times 3 times 4, and 2 times 4 times 1. That's 6 plus 24 plus 8, and that's 38. So we're getting smaller and smaller numbers. And the last one, we have 2 times 2 times 2, 2 times 2 times 3, and 2 times 3 times 2. So that's 8 plus 12 plus 12, and that's 32. I guess it makes sense. Like if the more our rectangular box looks like a cube, the smaller, well, its surface area will be. So yeah, the answer is 32. Okay, let's move on. Question number 3. Cut 2 squares of side length 1 and 2 congruent rectangles from a piece of 16 by 10 rectangular paper. Okay, I see here we have 16. This is 8. Well, I guess maybe this part is 8. And because we just cut off 2 rectangles there, so we have 1 here, 1 here. So in total, the length here is 10. That's the 16 by 10 rectangle. Well, what's the volume? Okay, so first of all, we should fold parts of the rectangle up. Some of the rectangles here up to form walls of the rectangular box. Okay. I guess here we have the question, like, what's the length of this part? Let's see. So I guess here we need to make another rectangle. So we have so the part in the middle is like the bottom of the box. It's bottom. And then we have the left, we have right, we have that's back and front. So this big part should be the top of the box. This is top. Okay. The total length here is 16, and we have 1 and 1. Those 2 parts are like the height of the box, and that means we have the sum of those 2 should be 14, but they are equal, right? They're like the length of the our box. So each of them should be 7. 7 here and 7 here. Okay, now we know that after we just fold everything, then we have a nice rectangular box, and it's 1 by 7 by 8. Cool. Then the volume is 56. Okay. Let's move on. Next one. Mark uses 3 ribbons of lengths 36, 32, and 28 to bind a rectangular gift box. What's the volume of the box? Yeah, again, to find the volume, we need to know the length, width, and height. So let's do 3 variables. We do A, B, and C. Okay, then using the length of those ribbons, I guess we have equations. So for example, we have this part is C, and then B, and then C again, and then B again. So it's like twice of B plus C. So we have 3 equations. 2 times A plus B, 2 times B plus C, 2 times C plus A. It doesn't matter which is which. Let's just do 36, 32, and 28. Then we just need to solve equations here. Now let's first simplify. I guess we can divide everything by 2. So we have A plus B is 18, B plus C is 16, and C plus A, that's 14. Cool. You can, and then we can take the sum of the 3 equations here. That's usually what we do when we have equations that look pretty symmetric. Yeah, if we take the sum, then we have 2 times A plus B plus C, that equals 48. So A plus B plus C, that's 24. And then using the 3 equations here, we can find the values of A, B, and C. So here A is equal to 8, B is equal to 10, and C is equal to 6. Okay, and then we can compute the volume. That's just A, B, C. So 480. All right, yes, we can move on. Question number 5. The area of 3 faces of a rectangular box is 96, 120, and 180. What's the volume of the rectangular box? Cool. So assume that the rectangular box is like A by B by C. So rectangular box A, B, C. And then we know that we have 3 conditions there. So AB is 96, BC is 120, CA is 180. I guess the order here does not matter. So our goal is to find the volume. And yeah, again, the volume is just the product of the 3 numbers A, B, C. That's the volume. Okay, so I guess here we can take the product of the 3 equations, because then the left-hand side would be just A squared, B squared, C squared. So AB times BC times CA, that's 96 times 120 times 180. Then we just need to take square root. So A squared, B squared, C squared is equal to the product. And then A, B, C is square root of 96, 120, and 180. Cool. So when we take square root of something, if we want to simplify that, then we're just looking for squares under the root. And then whenever we see a square, we can get it out of the root. So yeah, let's see. 96, that's 6 times 16, and 16 is a perfect square. 120, 180. So we see 12 times 10 and 18 times 10. Okay, so at least we can have a 4 here and a 10 here from the 16 and 10 times 10. Now under the root, we have 6 times 12 times 18. Okay, so 4 times 10 times, here we have 6 times 2 times 6 times 18. And 2 and 18 make 36. So 6 and 6, that's also 36. Okay, so we'll have 4 times 10 times 6 times 6. Cool, so that's 1440. And that should be our answer. Cool, next one. So the solid shown is formed by taking a 3 by 3 by 3 cube and drilling a 1 by 1 hole from the center of each face to the center of the opposite face. Cool. So from top to bottom, front to back, and left to right. So 3 holes. What's the volume of the solid? I guess we can just look at that. Look at the 3 layers. So for the top layer, I guess we're just missing the one in the middle. So top, wait, so something like this. So we're just missing the square in the middle. So this is the part we have, and the volume is 8. That's the top layer. And for the middle, it seems that we only have the 4 corners. 4 corners here. And the volume is 4. And for the bottom, that's the same as the top because super symmetric. So again, we're just missing the cube in the middle. So the volume is 8. Then we can just take the sum. And that's 20. Okay. Yeah, that's it. Let's move on. A 120 by 120 by 120 cubic tank is partially filled with water of height 100. Yeah, let me draw it. So we have a cube and a lot of water there. The water is right here. Okay, then we have a cubic iron of side length 60. We put that into the tank. Then what's the distance from the water level to the top of the tank? Cool. So we put a cubic iron into the tank, then I guess the water level will rise. So let me draw a like a cube here. It's iron, so it will definitely be at the top of at the bottom of the tank. And now the water level will go up to somewhere here, the green, the green face there. Okay, now if you think about it, then if you look at the water, it used to be just this nice in this nice rectangular box, the water. But right now, it's a larger rectangular box with a hole there. Like if you only look at water, not iron. So there's a hole. So that means if we take that very thin layer of water and we should be able to put that water into the hole right here. Then I guess we have we know the volume of that very thin layer should be 60 times 60 times 60. That's the volume, and then we know the height of that very thin layer of water because we know the length and width, and both of them are 120. So the height, this small part is h. So the height times 120 times 120. That's 60 times 60 times 60. Okay, so h is 15. All right, it's not that thin, but yeah, we want to find the distance from the water level to the top of the tank. Used to be 20, but now the water level goes up by 15. So the distance should be 20 minus 15. That's 5. Okay, yeah, that's problem number 7. Let's move on. A 12 by 10 by 8 sealed tank is partially filled with water. Okay, so first the tank is put on a 12 by 8 face, then it's put on a 10 by 8 face. If the water level increases by 1, then what's the volume of the water? Cool. Guess it's a perfect time to set up some equation using the volume of the water. So let's say the height here is x, and then the height becomes x plus 1. Yeah, because the water level goes up by 1. But what's not changed is the volume of the water, right? So we have 12 times 8 times x. 12 times 8 times x, and that equals 10 times 8 times x plus 1. Okay, we cancel out the 8. We have 12x, that equals 10x plus 10. So x is equal to 5. Okay, then we know the volume, right? Just 12 times 8 times 5, that's 480. Okay, let's move on. Question number 9. A cubic container without lid is filled to half its depth. Tilt the container along the edge AB. The maximum angle in degrees through which the container may be tilted from horizontal position without spilling is what? Okay. If we tilt it, then yeah, let me draw the picture here. It's not easy, but I'll try. Along AB. Okay. Not a super nice picture. Yeah, we have A and B here. So I guess here we can look at the cross section. For example, the cross section here. And after we tilt it, the best we can do is the 45-degree angle, because now if we look at the cross section, the water is right here. And the volume matches, right? If you compute the volume here, that's half of the cube. And if you also compute the volume here, it's also half of the cube. So the volume matches. And now if you do it larger than 45 degrees, then I guess some water will get spilled. So yeah, I guess that's the best we can do. So 45 degrees there. Okay, let's see next one. Cut a wooden cube into 2 rectangular boxes. The ratio between their volumes is 5:6. Okay, if the corresponding ratio of the surface areas between the 2 rectangular boxes is m/n, and what is m plus n? Cool. So we don't know the side length, but because of the ratio here, 5:6, I guess it's a good idea to assume that the side length is 11, so that we can just work with integers. Yeah, so assume side length is 11. Then we need to compute surface areas. We have 11 here, 5 here, 6 here, then 11 everywhere. Cool. So for the smaller one, if you compute the area of smaller one, the surface area, then it's 5 by 11 by 11. That's the dimension of the cube. So the surface area is 2 times 5 times 11, 2 times 5 times 11, and 2 times 11 times 11. For the larger, we simply change the 5 to 6. Okay, then we want to find the ratio. Okay, so the ratio, I guess we can cancel out the 2 and also a 11. Then we have 5 plus 5 plus 11 on top. We have 6 plus 6 plus 11 on the bottom. So that's 21 over 23. They are already relatively prime to each other. And yeah, so m plus n should be 21 plus 23. That's 44. Cool. That's for problem number 10. Okay, question number 11. So the following are three different views of a three-dimensional figure made from cubes of side length 1 from A, B, C, or D. What's the surface area of the correct figure? Okay, so if you look at the A, B, C, and D, only D satisfies all three views, the top, front, and side. So yeah, you can simply just compute the surface area of part D. And there's a clever method here. So to compute its surface area, we can just do 2 times the top plus the front plus the side. So that's like if you look at the figure from top, from bottom, from front, from back, from left, and from right. So we'll have a number here, but that's not the final answer because there are 4 faces that cannot be seen from any of top, bottom, left, right, or front and back. So those are the, like, for example, that face cannot be seen. And there are 4 faces like that. So we need to add 4 to that. And yeah, the final answer is 38. Okay. Yeah, next one. Which of the following can be folded into a square pyramid? So a square pyramid, it's like we have a square base and then we have a point outside of the base, and we just connect that point to the 4 vertices there. So that's a square pyramid. And yeah, which of them can be folded into a square pyramid? Yeah, I guess here we have to use our imagination, or we can draw the top view of the pyramid. So I think I can do some coloring here. Let's say we fold this one and eventually want to get a pyramid like this one. So like the top view of the pyramid. So let me do some coloring here. Okay, so if we want to fold this triangle up, then in the top view, it's going to be this triangle here. So let's color them using the same color, purple and purple. Okay, and now if you think about the triangle, the bottom left triangle, wait, what? Internet connections unstable. Shit. All right. Question number 12. So which of the following can be folded into a square pyramid? Okay, so square pyramid, it's like we have a base, and the base is a square. And then we have a point outside of that plane, and we just connect that point with the four vertices there. And then that's a square pyramid. Okay, so which of the following can be folded into a square pyramid? Let's see. So I guess we can look at the top view of the square pyramid. It's going to be something like that. This is the top view. And let's do some coloring. So if you think about the first shape there, if we fold that triangle up, then eventually that triangle will be this one here. Like this is the top view of that triangle. So let's color them using the same color. Let's do purple. And if you look at the bottom left triangle here, after you fold it, it's probably gonna go there. So let's do green. And of course we have red, red. But then this bottom right triangle might be an issue because after we fold it, it will probably go here. Cool. So yes, we're not gonna make a square pyramid. So yes, not A. Let's look at B. So again, let's do some coloring here. Red, red, purple, purple. If we fold this one up, then this triangle will go here. So green, green. Okay. So the last triangle, if you fold it up, and then the green triangle goes here, then the last one will go to the last place there. So everything worked out. And yeah, that should be our answer. Let's also take a look at the last two, just to make sure. So for C, guess we have red, red, purple, purple. But now there's some issue with those two triangles. If you think about that one, I should go to the purple one there. But it's already, that spot is already taken. So yeah, there's an issue there. And for part D, let's see. Red, red, purple, purple. And then green, green. Now, if you think about the last one will probably go to the spot that's already taken by purple. So yes, that one doesn't work either. Okay, so the correct answer is B. Okay, let's move on. Number 13, Austin has a full glass of juice. His brother Benjamin brings an empty, bigger glass and shares juice equally with him. Both cups are in the shape of cylinders. Okay, the ratio between their radii is 2 to 3. Okay, if the height of Austin's glass is 36, what's the height of the juice in Benjamin's glass? Okay. So Austin has a full glass of juice. So let me draw two cylinders. So here is Austin's cylinder, or let's just call it cylinder A. We also have cylinder B, and the ratio between their radii is 2 to 3. So I guess cylinder B has a larger base. Cool. And it's empty right now. So they want to share the juice equally. Okay. We also know that the height of Austin's glass is 36. So here's 36. Radius here is 2. Well, it's not necessary 2, but we know the ratio is 2 to 3. So let's just do 2. And the radius of cylinder B is 3. Okay, here, I guess we need, we already told that the volume of the cylinder is computed using pi r squared times h. R is the radius of the base and h is the height. So that's the volume. Okay, so I guess Austin will keep half of the juice here. So half of the juice will go to cylinder B. And the volume should be the volume of the juice that Benjamin will get. It's like pi r squared times 18. Okay, so let's say the height of the juice in Benjamin's glass is h. After they share the juice, then we know that it's pi 2 squared times 18. That should be equal to pi 3 squared times h. And here we can find the value of h. So h is equal to 8. So yeah, this question is just about the volume of cylinder. And we do have the formula here. Cool. Let's see next one. Problem 14. Remove a cylinder of a radius 2 and height 10 from a solid cube of side length 10. What's the surface area of the remaining part? Cool. Interesting question. So the surface area of the remaining part, that equals the surface area of the cube. Surface area of cube. But then we remove the top circle and the bottom circle. So minus top circle minus bottom circle. But at the same time, we created some surface inside. So that's the side of the cylinder here, the side face. So we need to plus the side of the cylinder. Cylinder. Okay, we can compute. So surface area of cube, that's 6 times 10 squared, because side length is 10, 6 faces, minus top circle. The circle has radius 2, so minus pi times 2 squared, minus bottom circle, so minus pi times 2 squared. Now the side of the cylinder, its area can be computed by the perimeter of the circle times the height of the cylinder. So it's 2 pi times radius, which is 2, and then times height. Okay, so 600 is minus 4 pi plus 40 pi. Yeah, 600 plus 32 pi. And we're told that we should take pi to be 3. Not a super good estimate, but let's do it. 600 plus 96. So 696. Yeah, that's the answer. Oh, cool. Let's move on. Okay, this question is about cone. A sector of x degree and radius 5 can be folded into a cone. I guess we can just glue those two radii together, which has a height 4. Okay, so after we glue them together, we have a cone and the cone has height 4. What's the value of x? So for this type of question, the key is to look at the red part of the graphs here. So that's the arc of the sector and also the circumference of the base of the cone. So if you think about it, then those two are actually the same thing. Like you have the arc here, but after you glue the two radii together, then the arc becomes the base circle. So we can use the length of the arc to set up some equation here. On the left-hand side, to compute the arc length, we do the perimeter of the circle, or the circumference of the circle, which is 2 pi times 5. And then we know the sector is part of the circle, and the ratio there is like x over 360. Right, because if we go around the point once, then it's 360. And now it's only x. Okay, on the right-hand side, if you compute the circumference of the circle, of the base circle, then we need to know the radius. But the radius is 3 because we have a 3, 4, 5 triangle here. That's 5 because that's the radius of our sector. So 5, 4, and that means the radius of the base should be 3, Pythagorean theorem. Okay, then its circumference is 2 times pi times 3. Cool. So now we can find the value of x. So x equals 3 times 360 over 5. And yeah, that's 260. Cool. Yeah, just remember, keep in mind that whenever you have a cone, this, making a cone from a sector, then the key is to look at the arc here and also the circumference of the base circle. All right, that's problem 15. Let's move on. Coordinate geometry. All right, so in the diagram, which of the following points is at a different distance from P than the rest of the points? So first of all, we can just read the graph, read the diagram here, and we can find the coordinates of points. For example, for P, we know the coordinates are just 5, 2. Yeah, so the 5, 2 basically describe the location of the point P. It's like you start from the origin, and then you think about the number of steps you need to make to the right, and the number of steps you need to make up to go to the point P. So 5 steps to the right and 2 steps up. So yeah, that's why the coordinates are 5, 2. And yeah, you can find coordinates of everything. So for A is 2, 3, for B is 4, 5, for C is 6, 5, for D is 7, 4, and for E is 8, 1. So here, we want to find the distance between some of the points here. And the way to find distance is to use Pythagorean theorem. For example, if you want to find the distance between P and A, then we know it's square root of 5 minus 2 squared plus 2 minus 3 squared. So essentially, we're looking at this triangle here. Right, so right triangle, and here's 5 minus 2, that's 3. And here, the distance here is 3 minus 2, that's 1. So it's a right triangle with 2 legs, 1 and 3. And the hypotenuse should be root 10. So yeah, similarly, you can find all of the distance here. So you will see PB, PC, PE, they're all equal to root 10. Well, actually, you can just look at the graph. For example, this PC, you can see that there's a right triangle there with two legs, 1 and 3. So hypotenuse should be root 10. But this PD, that's quite different. PD, if you compute the distance, then that's 2 root 2. So different from the rest of the distance there. So yeah, the answer is D. Okay, let's move on. Problem 17. In the diagram, points 2, 6, 2, 2, and 8, 5 form a triangle. The area of triangle PQR is, looking at the graph, we see that this PQ is actually vertical. That's nice because then it's very easy to find the height that corresponds to PQ. So here's the height. I guess we can just count like 1, 2, 3, 4, 5, 6. So the height is 6 here. And the base, that's 4. So we just do half times base times height. So that's half times 4 times 6, that's 12. Okay, let's move on. Piece a point on the line 3x plus 5y is equal to 16 that has equal distance from the coordinate axis. What's the sum of coordinates of P? Okay, so I guess it's a good idea to draw the graph here, just to get a sense of what's going on. Coordinates x, y, 3x plus 5y, that equals 16. Let's see. I guess we do have the point 2, 2. That is on the line. So yeah, this point, let's say, is 2, 2. 2, 2 is on the line. And then let's find another one. If x is equal to -3, then y is equal to 5. Okay, so x is -3, y is equal to 5. Somewhere here. Then we would just connect the 2 points to draw our line. Okay. Not super accurate, but I think it's fine. So point P is a point on the line that has equal distance from the coordinate axis. Okay. I guess we already have the point. 2, 2. Yeah, if you look at other points, like over here, let's see. Over here, there might be a point. So let's see, maybe there's a point here with the same distance. Yeah, let's see. Let's say we have the point somewhere here. Since it has the same distance from the coordinate axis, then let's say the coordinates of that point is maybe -a and a. And a is a positive number. And we also know that the points on the line, that means -a and a should satisfy that equation. So that means 3 times neg a plus 5 times a, that equals 16. Okay, so we have a is equal to 8. So that is possible. Okay. Yeah, let me double check the question. Cool. It seems that the point neg 8, 8 does satisfy all of the conditions there. So that's one possible point. And yeah, if the point is here, then I guess we already see the point 2, 2. But if you want a more rigorous solution, then you can assume that the point is like A and A, because same distance to the axis. And then you can plug in like 3a plus 5a, that's 16, and you will see a is equal to 2. So we already have a point here, 2, 2. Very lucky. And then when the point's over here, I don't think it's possible. So it seems that x coordinate here, or the distance to the y-axis, is always larger than the distance to the x-axis. So yeah, not possible over here. So I guess we actually have two different answers. So this p can be neg 8, 8, oops, neg 8, 8, or 2, 2. So if you look at the sum of the coordinates, then that's neg 8 plus 8, so that's 0, or 2 plus 2, that's equal to 4. So I guess two answers here, 0 or 4. Okay, let's move on. Right, what's the area of the triangle formed by the line y equals 2x, the line x plus y is equal to 6, and the y-axis? Again, it's a good idea to draw the graph. And it's very easy to draw. We have some nice numbers there. Y equals 2x. I guess we can find the point 1, 2. And yeah, that's the line y equals 2x. We also have the line x plus y equals 6. Let's find some points there. For example, I see the point 2, 4 is on the line. And also like 6, 0, 0, 6. Okay. Yeah, let's say that's the line. And also the y-axis. Y-axis right here. Cool. So they do form a triangle right here. Want to find the area of this triangle. So I guess we can just do base times height. So to find the base, we need to find the coordinates of that intersection. So x plus y is equal to 6. The intersection with the y-axis. This is just like solving equations, right? The y-axis is like x is equal to 0. And then if you also want x plus y to be 6, then I guess x is 0, y is 6. So we do have the coordinates 0, 6. And we also need to find the coordinates of that intersection. So y is equal to 2x and x plus y is equal to 6. If you solve the equations here, you will see x is equal to 2 and y is equal to 4. So 2, 4. Yeah, we'll find intersections of two lines. Then it's just like solving the equations together at the same time. All right, so now we can do the compute the area. So 1/2 times base times height. Height is 2, right? This height here is equal to 2. So the area is 6. Cool. Last question there, problem 20. Find the area of the trapezoid formed by 4 lines. Y is equal to 2x minus 4, y is equal to 8, y is equal to 0, and x is equal to 0. Again, let's draw the graph. We have x is 0, y is 0. That's the y-axis and x-axis. And also y is equal to 8. That's a horizontal line. So y is equal to 8 here. Okay. We also want to draw the line y equals 2x minus 4. So when x is equal to 0 is negative 4. When x is equal to 2, that's equal to 0. Okay, so something like that. Now we do have the trapezoid. Yeah, this line is y equals 2x minus 4. Cool. So to find the area of the trapezoid, we do this like the sum of the two bases times height, and then times 1/2. So when the height here is easy, that's just 8. Then we need the two bases here. That's again like solving equations. So if you look at the base on top, well, it's like solving those two equations at the same time. So y is equal to 8 and x is equal to 6. So the intersection here, 6, 8. And similarly, here y is equal to 0 and x is equal to 2. So 2, 0. Now we can compute the area. So area of the trapezoid, that's 1/2 times the sum of the two bases, 6 plus 2, and then times height, that's 8. So 1/2 times 8 times 8, that's 32. Yeah, that's the answer. And that's it for the practice questions. So yeah, hope you enjoyed all of the questions. See you guys next time.